Oh, boy. Matt. Like pop your
I like Calc.
Mr. Yanks, what's your favorite addiction? What's your favorite addiction? Is what this guy has, and you relate to this problem. Mr. Yang's favorite addiction is teaching us about.
No, I don't. No, I don't.
Getting us ready to
like get my money down.
Favorite addiction.
I'm so ready.
No, I don't like Mr. Yang's favorite addiction is to do calculus. You don't want to CPAs out.
Let me just highlight a few problems from pages 1 through 4, and then we'll continue with our quiz review.
Yeah.
Page 2. Once we understand that these are just going to be exponential growth equation, P equals C to the KT, then you're just solving for your C and your K. So really, there's no calculus here. The only calculus is recognizing that, oh, this P prime equals KP is going to produce this differential equation. Sorry, this differential equation is going to produce this solution, and the rest of it is just plugging in. So you get to use your calculator on the quiz on Friday. But any questions with these? Do I need to go over any of these problems with you? So really just a bunch of algebra. You solve for C, you solve for K, or a problem where you may solve for K first and then solve for C. So just being aware of the different variations between these problems here. Okay. Page 4. These differential equation problems. If you can find y prime and y double prime, then you're just inserting whatever you found into your differential equation, and that will help you solve for K. So just treat K like you would like a number like a 3 or 5 or 6. All right, any ones you need me to go over on pages 1 through 4? All right, let's go to page 5. Okay, number 13, let's start with, let me read through this problem. All right, so at time t equals zero, a boiled potato is taken from a pot on the stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0, and the internal temperature of the potato is 7 degrees for all times t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h, which satisfies the differential equation. So we are at the derivative level, but they do give us an order pair at the function level, h of 0 equals 91. Write an equation for the line tangent to the graph of h at t equals 0. Now, normally when you think about tangent line, you're thinking, okay, y minus y sub 1 is equal to m times x minus x sub 1. Right? But for this problem, our variables are a little bit different, right? It's not x's and y's. It's going to be t and h, right? Anytime you see time involved, you want to treat that like your x. And so that means whatever the other variable is, it must be my dependent variable. So if I want to write my tangent equation, I don't see x and y's, but I do see t and h's. So I really want to put it into this form. And the order pair, instead of x1 and y1, it'll be t sub 1 and h sub 1. And they tell us that order pair is 0, 91. So there's my t and h. So I'm almost there. My tangent line equation is pretty much there. I just have to find the slope. How can I find the slope? What's available for us to use? Right. Do we have a slope formula that we can use? Good, DHDT, right? That's just another way of saying derivative. So we give it enough information. In return, it'll give us the number, and that number is our slope. So, but the derivative doesn't require time, it just requires h. So we just plug 91 in for h, get that slope, and then there's your point slope flow. And then once you have your tangent line equation, then you're going to use that to approximate the temperature at t equals 3. So you get your equation all set up, and then you can plug in 3 to get the internal temperature, just basically using tangent line equation and plugging in. Right. Any questions with part A? Part B says find d2h over dt2, and then we can use it to decide whether we have an under or over approximation of the internal temperature. So how do we get to that? Well, what is it asking us to find? Find the what? Yeah, find the derivative of the dt, right? d2h over dt2. So let's go ahead and set up the problem to allow us to do that. So if I distribute that -1/4 through, and now I can find my derivative. Okay, so we know that 27/4 would just go to 0. What's -1/4 h going to turn into? Good, right? Remember, we're finding the derivative with respect to time here, so h will become 1, but then we need to attach dh dt. And my second derivative is in terms of dh dt. I can replace dh dt back with this, right? So that will allow me to be able to start plugging information in. So I'll replace dh dt back with what we have here. And now the problem is asking, determine whether we have an underestimation or overestimation at t equals 3. We found from part A that the order pair is 343, right? So we can use that part A to help us figure out what our second derivative is. So if I plug 43 in, I'll either get a positive or negative number. If I get a positive number, what does that indicate to me? That the graph is experiencing what? Yeah, concave up, right? Concave up would be underestimation because my tangent line is always going to skim the surface below the curve. But if my second derivative is negative, that means my graph is concave down. If my graph is concave down, then any linear approximation is going to be over. So we plugged in 43. We'll get a positive number, and that's enough to indicate, okay, concave up. Any linear approximation is going to sit below the curve, it's going to skim the surface below the curve, and therefore we're getting an underestimation. Okay, part C is where we begin to go through our solving differential equation. We want to separate our variables, right? Normally, we like to separate variables where y's are on the left, x's are on the right, but here it's not x's and y's, it's t and g. So we'll treat time like x, and we'll treat whatever the other variable that we don't recognize, that's our y. Okay, does anybody still need to look at part B? Okay, so part C reads, for t less than 0, an alternate model for the internal temperature is provided by differential equation, dg dt, where g of t is measured in degrees Celsius, and we have an order pair, g of 0 equals 91. Find the expression for g of t, and then based on this model, what is the internal temperature at time t equals 3? So we have to go through our process, right? We'll separate the variables, take the antiderivative, solve for c using the order pair, get it up to a g equation, and once we have that g equation all spelled out, then we can use that to provide the temperature at a moment in time. Okay, so we're going to go through our full separation of variables, our full process here. So I like to start off by getting my fractions to show up so that I can cross multiply, so I can get my dg and dt set. All right, so we have dg and dt sets. Those two are not going to move. But do we have full separation of variables yet? No. What's out of place? Yeah, this whole parentheses, right? But what would you move over here to the other side? Would you move over everything? Yeah, I would just save that negative on the right side. Again, we just want to move what just the minimal amount to the left. If something doesn't have to be on the left side, I'm going to leave that on the right side. Okay, so we should have full separation now. Okay, full separation. We can now think about our integral rules. The right side is easy, right? That's just power rule. -1 becomes -t plus c. But the left side, what would you go through? So U substitution. Okay, what would your U value be? -27. Okay. And then after we go through U substitution, what rule do you expect to use as your antiderivative rule? Power rule. Good. Not natural log, right? I know we may be tempted with natural logs because we see that U value in the denominator, but it's not U to the first power. If it's used raised to any other power, you got to bring it up. You got to go through power rule. The convenient thing here is that the derivative is only producing a 1, so okay. So this is what my cleaned up left side looks like right before I jump into my antiderivative rule. So power rule on the left, power rule on the right. So after I apply power rule, add 1 to the exponent divided by the new exponent, I clean it up, bring back my original variable. Now I'm at the function level. So once you're at the function level, you just have 2 remaining tasks to do. We have to solve for C, and then we have to get G by itself. So I think this is a manageable place to just go ahead and solve for C. I'll go ahead and do that. And my order pair that's given to me is 0, 91. (91 minus 27 is conveniently 64. And cube root of 64 gives us a nice number there. Okay, C equals 12. Once you have your C value, go ahead and replace the C value. Yes. Okay. Once you have your C value, go ahead and replace it where you initially made that substitution. And then you can focus your attention on how can I get the G function by itself. So the remaining algebraic steps, I can divide by 3. I can cube both sides. And that way I can get that G to isolate itself. Cube both sides. That will release that radical into just G minus 27. And then just add that 27 over. So now that I have my G function, I can now use this to make a prediction as to the internal temperature at 3 minutes. So now I can plug 3 in, and whatever number I get is the prediction using this G function. Twelve minus 3 is 9. 9 over 3 is 3. 3 cubed is 27. 27 plus 27 is 54. Okay, 14. I want you to try 14. Similar procedure here. Number one, part A is easy. You're just, if it's asking you to sketch the graph, you just start with the point that they give you and just follow the path of the graph. That's easy. Write the equation of tangent line. That's similar to what we did for the previous problem. Get your slope, get your point slope form. And then part C, you can use concave up, concave down to make your estimation. And then part D is full separation of variables. So let's try those. Let me just see how you guys do with all your steps.
They're calculator.
Yeah, you get to use your calculator. But actually, sorry, try this without a calculator because there's you don't have to simplify your answers. So, so this problem on the AP exam is meant to be non-calculator. So let's just try it without it. You can leave your answer in unsimplified form. So all this can be done without a calculator. You don't have to get it down to 1.7. AP exam will accept that combination of numbers added, subtracted with decimals. Sorry, with decimal value. Part C, they're telling you the graph is concave up, so we just see a visual of a concave up graph, you know that any tangent line is gonna have to be below.
Let's see, you just look at the graph.
Sorry?
Let's see, are you just?
Part C, you're just sketching your own graph.
Oh, yes.
Yeah, because they're telling you the graph is concave up.
Yes.
All right, any questions A through C? Okay, D is the heart of the problem here. The most important skill I want you to be able to take out of this unit is, can you solve a differential equation? Right, so we're guaranteed to see it on the AP exam. It shows up on the FRQs. It shows up on the multiple choice. So let's see if we can go through our steps. Now, I've outlined a very specific way of the process for solving different equations, but if you are working through the problem a little differently, but you're still following algebraic rules and you're still getting the same answer as me and you're still showing all your steps, you're free to to veer away from what I'm doing. So you don't have to show me every single step in lockstep with mine, but I do need to see how you got to your answer. So it's different if you're separating variables, or if you're doing your steps a little bit different than mine. It's okay as long as you're able to get to the answer. So I'm purposely creating my set of fractions here so that I can cross multiply. And again, cross multiplying is not necessarily going to get you full separation, but it will get your dy and dx's into their right places. And then from there, your next decision is, okay, how can I, if the variables are still not separated, how can I divide in a way that will allow my y's to be together and then everything else on the other side? Okay, from here, we should see our y's and x's are not quite in the right places. So we need to move that root y plus 7 to the left. And at the same time, I'm going to go ahead and move that 2 back to the right side. Okay. I need to use substitutions on both sides of my differential equation here. For which one?
For root y plus 7.
Well, if we don't, then what rule would you use to take the antiderivative?
Can you just do power rule of y plus 7? And then make it like y plus 7 to the negative half power.
like this. Okay, push the next.
So then it would just be 2y plus 7, 2 times y plus 7.
Yes, you'll go through power rule, but there's a little bit of use substitution because there's a set of parentheses. Yeah, there's nothing that's gonna come out of that because you'll just produce one, but technically it's use substitution, but if you understand, okay, the derivative won't produce anything but one, then yes, that'll be just power rule. But imagine this is 2y plus 7 inside, and it's gonna produce a 1/2 that you're gonna have to keep track of. Yeah. Now that you're at the function level, you can go ahead and solve for C. The nice thing about solving for C right here is a lot of things will turn out to be 0, and we can quickly solve for C without having too much resistance here. So nice thing about cosine to the power 2, that just drops out to the 0. So that gives us a clean C value. We plug our 6 back into our equation, and now we just have all the algebraic steps. How do I get that y by itself? Then I'll divide by 2, square both sides. Okay. Now, at this point, you've already earned the majority of your points. The most important step is, can you separate your variables? Can you identify the appropriate integral rules? Can you take your antiderivative? Can you get that C to show up? Then solve for C, that's 1 point. And then your final point is, can you solve for Y?
Do we always have to make y like separate and totally open?
That's right. Yeah, at the very end, you should always, yeah, because it says, right, use separation variables to find y equals, right? So Final step, square both sides. Okay, we got through pages 5 and 6. You guys, homework. Your homework is just to finish 7 and 8, which is just the front and back of this worksheet 2 here. Yeah.
How did we go from 6 to 3?
I just distributed the 1/2 through, and I made it 6/2 is 3. You don't have to. You can leave all this mess and do a -7. You don't have to do it all that. But
Okay, so like if we just did -7 there.
yeah, Kate has this -7. Yeah. Okay, so your quiz is just going to cover these topics that we've been working through. Solving differential equation, slope fields, tangent equation, y = c to the kt problems. So I'll have a help session tomorrow morning. And then, but not Friday, because Friday I'll have a help session for my AB students. So tomorrow morning I'll have a help session, just practicing with more of these problems and problems that the last 2 pages that we didn't get to. I can work through that in the morning. So your homework again, pages 7 and 8. Tomorrow we need to start our next units, but gives you an extra day to study for your quiz, which is on Friday. Okay, back on your phones. You'll get to use your calculator on your quiz for Friday.